Hello friends, welcome back. Let's have an enjoyable session again today. Today we are going to discuss about chapter 4 of chemistry for the 9th grade, and that is structure of atom. Okay, so atom we have come to know from the previous chapter. We had atoms and molecules. What did it say? क्या कहता था उसमें वो कि any substance or I can say any matter is made up of atoms or molecule. एंड मॉलिक्यूल्स आर ऑल्सो बेसिकली मेड अप ऑफ एटम्स. तो यानी कि हर चीज के अंदर बेसिक फंडामेंटल ऑब्जेक्ट क्या है? एटम. एनी काइंड ऑफ मैटर, एनी काइंड ऑफ सब्सटेंस, इट कंटेन्स एटम इन इट. ओके, सो नाउ जब ये पता पड़ गया हमको कि एटम का बना हुआ है, तो स्टार्ट हुआ ये क्वेश्चन कि एटम कैसा होता है. एटम के अंदर भी कुछ है. लाइक डाल्टन थ्योरी वी हैड डन दैट द स्मॉलेस्ट पार्ट इज एटम एंड एटम कैन नॉट बी फर्दर डिवाइडेड. बट स्टिल फिर भी लोगों में यह ख्याल था कि क्या हम एटम के और सब पार्टिकल्स बना सकते हैं क्या, या एटम के अंदर और भी कुछ है, या एटम का स्ट्रक्चर है कैसा, एटम में कुछ कुछ और चीजें हैं तो क्या है, कहाँ है, कैसे हैं. सो दैट ऑल थिंग केम इनटू माइंड दैट व्हाट इज एक्चुअली एन एटम. सो दैट दिस चैप्टर डील्स अबाउट स्ट्रक्चर ऑफ एटम. ओके, सो विल प्रोसीड विद इट. व्हाट इट इज, व्हाट द पीपल सजेस्टेड, व्हाट वर द ड्रॉबैक्स, किसने क्या कहा, किसकी क्या कमियां थी, कैसे करके फाइनली व्हाट वी नो टुडे एंड व्हाट वी न्यू दैट टाइम. हाउ डिड द पीपल अप्रोच टू द टुडेज स्ट्रक्चर ऑफ एटम. ओके, सो लेट्स बिगिन विद द चैप्टर स्ट्रक्चर ऑफ एटम. सो इन दिस चैप्टर what are the topics, what are the things we are going to cover, we are going to study in detail, like the charged particles in atom. आ जाएगा इसमें कि हमने charged particles क्या क्या चीज जाना. Structure of atom, who people gave the ideas about the structure of atom, like Thomson's model, Rutherford's model, Bohr's model. We'll talk about that. And also how electrons are distributed in an atom, how are they placed. Then we come across the topics called as like valency, atomic number, mass number, atomic structures, isotopes, isobars, and fractional masses. So we are going to talk about all these topics in this chapter. One by one we'll go through it and see what do we learn, what do we discuss from this chapter. चलिए बढ़ते हैं आगे. Let's see what do we get in this very beginning. जो हमने अभी introduction आपको दिया, that's the same thing that from the previous chapters we came to know that all the matter, all the substance are made up of atoms and molecules. Molecules are also made up of atoms. Okay, we came. So I can say that the atom is the basic fundamental building block of a matter. एटम सबसे छोटा है. जैसे हम ईंट को जोड़ जोड़ के दीवार बनाते हैं, सेम वे एटम्स कंबाइन एंड फॉर्म अ सब्सटेंस और अ मैटर. आई कैन से इट मेक्स अ मैटर, एटम्स. ओके, सो people started thinking that there are different types of atoms. Why it is, why are the atoms of one kind of element different from the other kind? So the existence of different kinds of matter is due to different atoms. Okay, so we had different kinds of atoms, so we had different types of elements. Now the question arises, why are the atoms different? इसका एटम उसके एटम से डिफरेंट क्यों है? अगर if I take an atom of gold, how is it different from the atom of iron? Or I say the atom of an oxygen, how it is different from the atom of another gas. Let's take nitrogen. So how are the atoms different? Now the query came. People started thinking, what next? What is the difference between them? So these are the queries. What makes the atom of one element different from the atom of another element? What is the reason behind that? Are the atoms really indivisible as Dalton stated? Dalton theory, what was it? That this atom is the smallest indivisible part of an matter. So people thought, is it perfect or is there some changes to be done still? Okay, are there smaller constituents inside an atom? Atom के अंदर भी कुछ छोटे छोटे चीजें हैं क्या? So then people started thinking, experiments and this and that, proofs, justifications, all types of things started happening. And major challenges to the scientists at the end of the 19th century was to understand the structure of an atom, because before this we came to know that okay, substance is made up of, any matter is made up of atom. अब एक ही challenge था कि atom के अंदर क्या, या atom क्या है, कैसा है. That was the main challenge. 19th century, 20th century beginning, they were behind it, and ultimately by the end of this century, 19th or the beginning of the 20th century, they came with some conclusion. कुछ ना कुछ तो निकला. लोग लगे थे एक्सपेरिमेंट में, तो रिजल्ट तो आएगा ही ऑब्वियसली. सो दे वेंट ऑन एंड फाइनली they got something, they got a clue. कैसे पता पड़ा कि एटम के अंदर भी कुछ है? तो कुछ चीजें ऐसी हैपनिंग्स, नेचुरल फिनोमिनाज होते हैं जिसको देख के लगा कि यस समथिंग एल्स इज देयर. वन ऑफ द नेचुरल फिनोमिना, मोस्ट कॉमन नेचुरल फिनोमिना इज चार्जिंग बाय फ्रिक्शन. दैट यू मस्ट हैव स्टडीड इन 8th स्टैंडर्ड और 7th स्टैंडर्ड. चार्जिंग बाय फ्रिक्शन. ओके, हमने ही बताया था. फ्रिक्शन आई कैन से रबिंग. कभी भी कोई चीज को हम रब करते चार्ज डेवलप होता है. देखा कभी ऐसा? डिड यू सी दैट? डिड यू गेट इट समवेयर? यस. इफ यू टेक अ कॉम्ब and you browse your hair 2-3 times dry hair, and then you see that the hair gets stick to the comb, or bits of paper, small bits of paper get stick to the comb, or you take a scale, plastic की scale को आप बालों पे 3-4 बार ऐसे उसको रगड़ दें, and then you can see that it can attract pieces of paper. Why is it so? Why does it happens? Because that plastic gets charged by rubbing. Rubbing से हमारे कपड़ों में भी देखते हो कई बार ऐसा होता है, they gets charged when you change your clothes in the dark, some chatter putter noise comes. Okay, and some lightning, also small sparks. That is what that clothes gets charged by rubbing. That is called friction. So if a substance gets charged, where does it get charged from? Atom में ऐसा क्या है जो उसको charge दे रहा है? Something is there that gave the people an idea, hint that no, atom, it has something else in it that is providing the charge. क्या है वो? What is that thing? So it was here, the charging of the matter gave the first idea that atom is indivisible. There's something we can divide and it is not indivisible. Okay, so here you can see this activity जो अभी हमने बताया आपको, that if you take a scale, this boy, you can see there's a scale in his hand and he's rubbing the scale on his hair 2-3 times. If he rubs it and then when he puts it with the bits of paper, उस scale को अगर छोटे छोटे कागज के टुकड़ों से आप करोगे, then they gets attracted. Why does it happens? Because the scale gets charged. Okay, so conclude क्या किया हमने यहाँ पे? So we saw that the rubbing an object, it becomes electrically charged. Now the question is, where does the charge come from? वो charge आया कहाँ से? It gives an indication that atom is divisible. Atom के अंदर भी कुछ और है. There are some subatomic particles. उसके अंदर भी कुछ है, which is providing this charge. Okay, so ultimately, so people came with some conclusions. They went on, and many number of experiments went on. Research was done by the scientists to reveal the structure and particles. And by the end of 1900, it was there. By 1900, it was confirmed. It was confirmed that yes, the atom has subatomic particles, and one of the particle was confirmed. That was electrons. सबसे पहला ये ढूंढा गया था कि ओके एटम्स के अंदर एक नेगेटिव पार्टिकल है और उसका नाम दिया गया इलेक्ट्रॉन. ओके, J.J. Thomson was the person who gave this idea, who suggested this, who discovered it, you can say. So it was this identified by person. So J.J. Thomson was the scientist who discovered that any atom has a negatively charged particles in it, and those are called electrons. Okay, he gave the name electron to it. And another person, so many people more contributed to the structure or the shape of an atom or atom का structure क्या, कई लोगों का उसमें contribution है. One was J.J. Thomson, clear, about the electron. Then there was one more scientist, E. Goldstein. Now Goldstein ने कुछ rays identify किए थे. It was before this, in 1886. He discovered the presence of a radiations of charges which has positive charges, जिसको उसने नाम दिया था canal rays. Okay, so he discovered the presence of a new radiations in a gas discharge and called them as a canal rays, and this canal rays को आगे study करके इससे एक और particle find किया गया था, and that was having the charge same as electron. जितना इलेक्ट्रॉन का चार्ज है इतना ही इसका भी चार्ज था, but opposite, it was positive. So these rays were positively charged radiations which ultimately led to the discovery of another subatomic particle, another one more particles of the atom which has the same charge as the electron but opposite, means it has positive charge, and the name was given proton to that particle. Okay, so now it was confirmed that an atom consists of two things, one is electron, one is proton. Electron negatively charged, proton positively charged. This was confirmed. Now the question was, agar atom mein, in an atom if there is a proton, there are electrons and protons, where? There are, but where? What is the location? है कहाँ पर एटम के अंदर? ये ढूंढना थोड़ा मुश्किल था उस समय तो, but people they were hard to say that where it is. It is there inside, but कहाँ exact location है? Ideas लगाने लगे लोग, not find out what is it. Okay, so Again, experiments and research went on to find out. Okay, so by this time, what was clear now? That Dalton's atomic theory, what was it? That atom was indivisible. It is the smallest. Now that was a challenge given to it. That discovery of the fundamental particles inside the atom led to the failure of Dalton's atomic theory. Okay, I can't say exact failure, but we can say कुछ चीजें उसको हमने अपोज कर दिया. क्या अपोज किया सबसे पहले? कि एटम कैन बी फर्दर डिवाइडेड इनटू सब एटॉमिक पार्टिकल्स. उसका स्टेटमेंट था कि एटम कैन नॉट बी फर्दर डिवाइडेड, बट हियर केम दैट एटम कंसिस्ट ऑफ सब एटॉमिक पार्टिकल्स एंड टू सब एटॉमिक पार्टिकल्स एट प्रेजेंट. ओके, वन इज इलेक्ट्रॉन, वन इज प्रोटॉन. एक पॉजिटिव है और एक नेगेटिव है. पॉजिटिव कौन है? प्रोटॉन. नेगेटिव कौन है? इलेक्ट्रॉन. ओके, सो they have a inner structure. J.J. Thomson was the first person. सबसे फर्स्ट पर्सन हमारे इसमें कौन थे? J.J. Thomson. He came up with an idea of a structure of atom. He was the first person who proposed a model. सबसे पहले इन्होंने ही दिया आइडिया कि ओके द एटम इज समवट लाइक दिस करके उन्होंने कुछ एक स्ट्रक्चर दिया अपना. क्या स्ट्रक्चर दिया? दैट विल सी फर्दर. Let me give you a hint. He gave the idea that the atom is a solid ball type structure. Okay, आप मान सकते हैं उसको. It is a ball type structure which is totally positively charged. ओके और उसके अंदर इलेक्ट्रॉन्स डाले हुए हैं हमने उसके अंदर, क्योंकि हमारे पास टोटल चार्ज एटम क्या क्या आ रहा था? न्यूट्रल. पॉजिटिव भी है, नेगेटिव भी है. तो ही गेव द आइडिया दैट द टोटल पॉजिटिव चार्ज ऑफ एन एटम इज इक्वल्स टू द टोटल नेगेटिव चार्ज. ओके, इट इज नॉट दैट द एटम इज पॉजिटिवली चार्ज और नेगेटिवली चार्ज, बट it is neutral. So the total positive is equal to the total negative charge of an atom. So the model proposed by him, let's see what was the model given by him. So now that people started to know that scientists and peoples, उनको पता पड़ गया कि एटम जो है हमारे पास किस चीज़ का बना हुआ है, उसके अंदर कुछ पॉजिटिव है और नेगेटिव है. नेगेटिव में कौन है? इलेक्ट्रॉन्स है. बट ये नेगेटिव और पॉजिटिव है कहाँ फैले हुए, किधर है, कैसे स्कैटर्ड है, हाउ इज द स्ट्रक्चर ऑफ एन एटम, कैसे वो बेस्ड है पूरा. तो उसके लोगों ने अपने अपने जो साइंटिस्ट थे उस समय के दे स्टार्टेड गिविंग देयर आइडियाज. वन ऑफ देम वाज J.J. Thomson. Now J.J. Thomson was the person who discovered electrons also. Okay, so now here he gave his idea that what is the structure of an atom. What did he say? That the structure of an atom is same like a Christmas pudding model. Pudding model भी कहते हैं इसको, pudding model of an atom. What did he say? That atom is totally a sphere of positive charge. एक ठोस, एक solid sphere है जिसका चार्ज क्या है? पॉजिटिव, और उसके अंदर इलेक्ट्रॉन्स चिपके हुए हैं नेगेटिव चार्जेस, और सारे इलेक्ट्रॉन का चार्ज जो है वो पॉजिटिव के बराबर है. सो द टोटल चार्ज इज न्यूट्रल. सो ओवरऑल व्हाट डिड ही से? दैट एन एटम इज अ सॉलिड स्फीयर हैविंग पॉजिटिव चार्ज एंड नेगेटिव इलेक्ट्रॉन्स आर एम्बेडेड इन दिस स्फीयर such that the total negative charges is equal to the total positive charge, and hence the total charge is neutral of an atom. So he gave the model, you can see over here, a sphere which is totally positively charged and the electrons are embedded in this. Okay, a Christmas pudding model also we call this. Okay, so this was a model given by J.J. Thomson. Okay, so what it is? An atom consists of positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal and hence the total charge is neutral for an atom. So this was the idea proposed by J.J. Thomson. So you can see here, you can also compare this model. Okay, you can see here the pudding model, like the pudding is totally positive and the dry fruits put in the pudding or the currents, dry fruits को हम currents भी कहते हैं यहाँ पे. So those behaves like a electron. Or you can also compare with a watermelon model. Watermelon देखा ना, तरबूज को पूरा रेड कलर का. The complete red color is the positive charge. और जो तरबूज के बीज है उसको आप मान लो इलेक्ट्रॉन. So electrons are embedded, scattered all over inside. Okay, and the total negative charge is equal to the positive charge. So we call this model also a watermelon model also. Okay, so it's given over here. Thomson model of an atom can be also compared to a watermelon. The red edible part is the positive part and the seeds are taken as the electrons embedded in it. Okay, and the total negative charge is considered equal to the positive charge. So this was the idea given by J.J. Thomson and it prevailed. चलता रहा इसमें, but people were still thinking, is there something else? Is there some other possibilities also? ये जो structure था, it continued for long. till a time when someone else did an experiment. Okay, it was Rutherford who performed an experiment with his company people. दो और लोग थे उसके साथ में. They started an experiment. They did an experiment. They proceeded to the experiment with this thought only, and then but they came out with some other conclusion. उनका सोचना तो यही था कि ओके एक एटम है, सॉलिड है, कोई चीज़ उसे स्ट्राइक करेगा, यहाँ वहाँ स्कैटर होगा. बट जब उन्होंने एक्सपेरिमेंट किया तो कुछ और रिजल्ट आया. एंड देन दे केम विद सम न्यू आइडियाज. व्हाट वाज इट? लेट्स टॉक अबाउट. बट दिस वाज द फर्स्ट एवर given structure of a atom. Okay, one thing was clear, that atom has a positive charge and a negative charge inside it. Negative तो clear था, हमारे पास इलेक्ट्रॉन है. Positive कहाँ है, कैसे है, अभी तक confirm नहीं था. Okay, so now the next over here, before going to that experiment, let's come to here about a particle. Let's study a particle which is called as alpha particle. हम use करेंगे इसको कहीं पे. So alpha particle होता क्या है? Alpha particle is a combination of protons and neutrons. It is simply a nuclei of helium atom. You can say a nuclei of helium atom. Helium atom के आप electrons को हटा दो तो जो बचेगा वो बचेगा हमारे पास alpha particle. So it is a positively charged particle having 2 units of positive charges and 4 units of mass. It is 4 times heavier than AMU. It is 4 AMU is the mass, and it is actually helium ion He2 plus. The charge is 2 plus, and they are emitted by radioactive elements. जो radioactive substance होते हैं वो emit करते हैं इसको. Okay, like radium or polonium we have. They have a considerable amount of energy. They have energy due to which they can penetrate some bodies. They can penetrate our body also. They can penetrate solids also. So they are harmful. Overall, they are harmful. So it is not exposed. We should not be exposed to these rays. So, but these particles, they are used in certain laboratory experiments, in scientific research they are used. So here it was used in an experiment, okay, by Rutherford. So what did he do with these particles? So let's study about Rutherford experiment. After discovery of electrons and a positive charge, okay, so Rutherford thought, how are the electrons or how are they arranged in an atom? Let's study that. So for that he did an experiment in which he made the alpha rays, alpha particles strike the atoms, strike a atom. तो atom किसका लिया इसने यहाँ पे? Gold का. He was curious to know about the arrangement of the electrons, so he designed an experiment. Experiment को हम कहते हैं gold foil experiment. Rutherford's experiment is called as gold foil experiment. उस experiment के लिए he selected gold because he needed a thin sheet of metal. बहुत ही पतली sheet चाहिए थी उसको, okay? और gold is a very much malleable metal. पता है ना, malleable means it can be hammered into sheets. तो gold का बहुत पतला layer बनाया जा सकता है. So he took a very thin sheet of gold. Thin कितना था? It was thickness about 1000 atoms only. It was so thin, and he made alpha particles strike on that gold foil. So you expected the alpha particle strikes the gold foil, it will get scattered here and there. Scattering थोड़ी कम होगी. Why? Because gold foil alpha particle is a heavy particle. So he thought that since alpha particles were much heavier than the protons, he did not expect to see large diffraction. Okay, तो सोचा थोड़ा बहुत यहाँ पर होगा, स्कैटर होगा, कुछ भी होगा. He did the experiment. Okay, he made alpha particles strike the gold foil. Now what did he find? When he performed the experiment, what did he find? You can see in this figure. In this figure, what do we represent? This circle part is the circle part है हमारे पास यहाँ. These are the atoms of gold. Okay, these are gold atoms. And this line you can see over here, this is the alpha particles which are going this way. Okay, let me change the color so that you can easily see it. This way, the alpha particles going over here. So when the alpha particle went, he was surprised to see that most of the alpha particles went straight through the metal foil. They passed. They went straight without any deflection. Most of them went without any deflection. जो alpha particle एकदम center के atom के एकदम center में जा रहा था, that got deflected back. जो center से थोड़ा दूर थे, they got deflected like this away. It went over this way, it went over straight. So what did he find? Those alpha particles which were exactly toward the center, they rebounded back. Very few of them, very 1 in a 12,000, they were rebounced back. otherwise they went straight, and those who were near to the center line, they deflected at angles, very few of them, and most of them deflected by small angle or they went straight. You are surprised, how did they go straight? If an atom is solid, how did the particle go straight? So he told, no, whatever we are thinking till that day, according to J.J. Thomson, that the atom was a solid, it's not that. अब क्या conclusion आया कि atom के अंदर space है, खाली space है जहाँ से particles निकल के चले गए. So what are this? What is the new structure now? So he redefined the structure of an atom. उसने अपना conclusion निकाला. जो उसने observe किया, according based on this observation, what did he concluded? Let's see that. Whatever he observed over here, he concluded that, what did he see? Most of the fast moving alpha particle pass straight through the foil. Straight निकल के most of the particles. That same thing I have drawn over here. These are the gold atoms and these are the path of the alpha particles. Some of the alpha particles were deflected by the foil by small angles. Surprisingly, 1 out of every 12,000 particles appeared to rebound. 1 out of 12,000. Can you imagine? कितने कम, कुछ ही थे जो वापस आए, बाकी सारे चले गए. तो कुछ ही वापस आए. कौन से आए? जो एकदम सेंटर में जा रहे थे. So he came to conclusion that the center part of an atom has something. Otherwise the atom is empty. आर पार हो जा रहा. सेंटर में कुछ है जिससे हमारा अल्फा पार्टिकल कोलाइड हो रहा है या रिपेल होके वापस आ रहा है. So that was his conclusion. So based on this structure, what did he concluded? His conclusion was that most of the space inside an atom is empty. First thing. Why empty? Because most of the alpha particles went undeviated. They did not bend here and there, they passed off straightforward. So most of the space inside the atom is empty because most of the alpha particle passed through the gold foil undeflected. Second thing, very few particles were deflected from their path, indicating that the positive charge, the alpha is a positive charge. If it deviated means something positive is there to repel it. So it said that the positive charge occupies a very less space. Very few of them deviated means the positive charge is not scattered everywhere in the atom. It is at a particular point and very less space. What is the space? A very small fraction of alpha particles which rebounded back, bounced back at an angle of 180 degree, indicating that all the positive charge and mass of the gold atom were concentrated at that very small part. In a very small region, all the positive charge is concentrated, and that part he called it as a nucleus. He gave the name nucleus over there, and that is called as a nucleus. The center part of the atom is a nucleus, and that is very small as compared to the size of the atom. According to Rutherford, he gave the idea that an atom is not completely positive scattered everywhere. It is only concentrated at the center, and most of the space of the atom is empty. He came to this conclusion. Based on his conclusion, he gave a structure. He redefined the structure of an atom. He gave his own idea now, which is called as nuclear model of an atom. Rutherford gave the idea nuclear model of an atom, according to which there is a positively charged center in an atom called as the nucleus. Now he came to condition that in an atom there is a center part which is called as nucleus, where the entire positive charge is concentrated. पूरे एटम के अंदर सेंटर का एक पार्ट है जिसको उसने नाम दिया न्यूक्लियस, और सारा पॉजिटिव चार्ज वहीं पर है, पूरे एटम में नहीं है. एंड द मास ऑल्सो इज कंसेंट्रेटेड ओवर देयर ओनली, बिकॉज इफ अल्फा पार्टिकल इज बीइंग रिबाउंडेड, अल्फा पार्टिकल हैवी चीज है, हैवी चीज को वापस रिपेल करना है तो उधर भी कुछ हैवी चीज होना चाहिए. सो ही सेड ऑल द मास ऑफ द एटम इज कंसेंट्रेटेड एट दैट सेंटर ओनली. ये उसका कंक्लूजन था. उसी पे उसने ये लॉ बना दिया. लॉ क्या, स्ट्रक्चर बताया उसने अपनी तरफ से. An atom consists of a nucleus where the entire positive charge is concentrated and the entire mass of the atom is concentrated over there, and that point he called as a nucleus. The rest of the atom is empty space. What happens in the empty space? The empty space, the electrons occupy those empty space. The electrons revolve around the nuclei in that empty space. Same as a solar system. हमारे सोलर सिस्टम में क्या है, सन सेंटर में चारों बाजू प्लैनेट्स घूम रहे हैं. यहाँ पे सन की जगह कौन है, न्यूक्लियाई, द न्यूक्लियस, सॉरी, द न्यूक्लियस सेंटर में, और चारों बाजू इलेक्ट्रॉन्स उसके गोल घूम रहे हैं. सो ही गेव द आइडिया दैट इलेक्ट्रॉन्स रिवॉल्व अराउंड द न्यूक्लियस इन अ सर्कुलर पाथ. the size of the nucleus is very very small as compared to the size of atom. Very small, most of the space is empty. अगर आप एटम को हमारे क्रिकेट का स्टेडियम जितना बड़ा कंसीडर करो तो क्रिकेट बॉल इज माई न्यूक्लियाई. कैन यू इमेजिन? कंपेयर द साइज, इतना बड़ा एटम, न्यूक्लियाई कितना छोटा सा. सो दैट इट इज ओवर हियर. Clear? So this was the idea proposed by Rutherford. We can see here also. So what did he say? That suppose this is the atom, this is the nuclei, and the electrons revolve around in a circular path over here around the nuclei. So around the nucleus the electrons revolve. This is the atom and center part is the nucleus, and all the positive charge is concentrated over here only in this much part. All the positive charge is here. Even the mass of the complete atom is concentrated over here only. Electrons आजू बाजू में है तो electrons का mass negligible है. आपने देखा था बहुत ही कम है. So we can compare to the positive part, the mass of the electrons are negligible. So we say that the complete mass is concentrated at the center. This was the idea proposed by Rutherford and it was called as nuclear model of an atom given by Rutherford. But still questions are there to put always. So drawback उसमें क्या था, उसने बताया ये, but there are still people who question it. कोई भी law बनेगा तो question होगा कि does it satisfy everything? People said that a major drawback was there in this model whatever he gave. According to physics, if anything revolves over here, according to electromagnetic theory of physics हम कह सकते हैं, if a charged particle is in a circular motion, it gives out energy, it radiates energy. Circular motion is an accelerated motion. So if a charged particle accelerates, it radiates out energy. सीधी सी बात ये है, कोई भी charged part जब accelerate करता है वो energy release करता है. So it is a circular motion over here. The charged part is electron. It will lose energy, and once it start losing energy, they should slowly come towards the nucleus and finally collide with the nucleus. Energy lose करते करते धीरे धीरे वो न्यूक्लियस की तरफ आके और न्यूक्लियस से उसको अटैच हो जाना चाहिए या उससे टकरा जाना चाहिए. जो भी इलेक्ट्रॉन यहाँ पे रिवॉल्व कर रहा है धीरे धीरे उसको अंदर ऐसे आते 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 फाइनली इट शुड कोलाइड विद द न्यूक्लियाई. पीपल सेड दैट दिस इज द लॉ ऑफ फिजिक्स. इफ इट इज एक्सेलरेटिंग इट शुड लूज एनर्जी, एंड बाय लूजिंग एनर्जी इट शुड कोलाइड विद द न्यूक्लियाई. बट इट इज नॉट हैपनिंग. इलेक्ट्रॉन तो गोल गोल ही घूम रहा अपनी जगह पे. व्हाई इज इट सो हैपनिंग? Rutherford could not explain this concept. Okay, so that is a limitation you can say, or you can say that that was the drawback of the Rutherford atomic model. But जो उसने कहा वो था, he said that whatever things that the atom is there is a nucleus, there is empty space. ये बातें उसने कहा वहाँ पे. So now how to correct this? इसको correct करने के लिए again research went on. Then one more person came, Niels Bohr.
To watch the complete video, download the Upbind educational app from Play Store and App Store.